So today we're going to look at kind of the two steps I would suggest that you do for now. There's going to be more ideas behind this. But the first thing you need to know is that your function has to be rational. And like I just got done saying before we started the recording, that means there's a variable in the denominator. The easiest example is 1 over x, because you've seen that one. But there's lots of them out there. There's a ton of them. And obviously, if we're talking about 1 over x, it's the easiest one to talk about. This one here says to determine vertical asymptotes. What you're going to do is set the denominator equal to 0. Well, of these two, which one's the denominator, the 1 or the x? The x is the denominator, right? And the reason we set that equal to 0 is, do you agree if I had this, that's a problem? Huge problem, isn't it? Because that's the one thing not defined in math, dividing by 0. And then if you take a look at the graph, don't you agree that I showed you that little imaginary line right there that was in there? Do you agree that's vertical? And where's it at? At 0. Because when I set this equal to 0, what I get 0. And do you agree I can't possibly put a point on there? I can't. Okay. And so that's how you find verticals. Now what if I gave you something like this, x minus 1? Can you set that denominator equal to 0? So can I actually get something else then? Well, what do you get then? What x value actually makes the bottom 0 then? So when x equals 1, that's a problem, isn't it? Why? Because the denominator is 0. Now wait a minute. Wait. Didn't I already show you how to graph these? Isn't this just your parent graph moved right 1? Oh, where's x equals 1? Right 1. How about that? That's just amazing how that works. So some of these you already know how to do, but some of them are much more complicated. So what you need to know for right now is step 1. If you have a rational function, set the denominator equal to 0. Whatever happens to be down there, set it equal to 0. Find the places that cause a problem. Those will be your vertical asymptotes. You agree x equaling a number is a vertical line. Okay. Step 2 is to find horizontals. Horizontal is going to be y equals a number, right? Those are your horizontal lines. Y equals a number. And I'm going to give you 2 options for today. If the numerator and denominator have the same degree, just look, so top and bottom are the same, for example. You agree that's a rational function. Why do you say that's a rational function? There's a variable in the denominator, right? X squared. Is there more stuff in there? Yeah, minus 3. Does that matter? Not really. You just need a variable. There's one there. So do you agree that my numerator and denominator have the same degree? Well, what's the degree of my numerator? We did this way back at the start of this chapter. 2, right? What's the degree of the bottom? How'd you do that? You found the biggest exponent, right? All you have to do, so if that happens, just look at the fraction. And the fraction I'm telling you to look at is this one right here. 1 over 1, the one that's on the variable. So that's y equals 1. So it's y equals whatever that fraction is. So what if there was a 2 hidden down here? Do they still have the same degree? Is it still 2 and 2 for degree? So has the fraction changed, though? And now it's y equals 1/2. What if I put something really strange and put a 10 up here? Has that changed the problem a little bit? Yeah. Are the degrees still the same, though? They are. And now it's y equals 5. Does that change where that horizontal line is? Changing those numbers? It does, doesn't it? Y equals 5 is way up here. Y equals 1/2 down here. Y equals 0 way down. All right? So that's if the degrees are the same. The other one is if the denominator has a higher degree. This one's easiest. That's an automatic answer. If the denominator has a higher degree, can somebody give me an example of one where the denominator has a higher degree than the numerator? Yes. Okay, no, that's not what I'm looking for. I know what you're trying to say, but not what I was looking for. Yeah. X plus 4 on top. And? Okay, so x plus 4 over x squared plus who cares? As long as it's just a number. What's the degree of my numerator? 1. What's the degree of my denominator? Is the degree on the bottom bigger? This is an automatic answer. y equals 0. You don't have to do anything. Bottom 0, y equals 0. So let's put this in action and see if I can actually get you to do it. These are the shortcuts, believe it or not. You know what they really want you to do? Step 1's the same for what the book wants you to do. Step 2, they want you to take the inverse. Do you think an inverse of a rational function is going to be really easy to take? There was a yes and a lot of sarcasm with it. Yeah, that's not a whole lot of fun. Okay, and that takes a lot of work. So if you can learn these shortcuts, it saves you a ton of time. So let's try one. Do you agree that is a rational function? X over x minus 1. Okay, step 1, look for numbers that would make the denominator 0, or in other words, set the denominator equal to 0, right? I mean, right? And so you would do, here's your denominator, set it equal to 0, you add 1, right? This is if you actually had to do the algebra. I think most of you notice that if I put a 1 right there, the denominator is 0. Is that the only value that will make the denominator 0, or are there more? That's it, right? That's the only one, right? So x equaling 1. That right there, do you agree I can graph that line? X equals 1 is a vertical line. Do you agree with that? But right now, do you agree it's also the vertical line that causes a problem in my function? It makes a 0 on the bottom, right? So I'm not allowed to graph there. So that's called an asymptote. Not allowed to graph there. X equals 1, there it is. I'm not allowed to graph there. So that's why I put it, you don't have to make it red, all right? Just make it red so you can see it. But just make it dash, and you can dash it off to the side or something like that. Just give yourself a little XY table over there or something. Because I didn't give you one today. A little axis. All right. So have we found all possible vertical asymptotes? Yes, yeah, that's the only one that's going to make that happen. Now, again, step 2 is where they want you to do this inverse and do all this stuff. Remember, to do inverse, you have to switch x and y, so I have to make both of these x's y's, and then I have to get them by themselves. That's a lot of work. This is way quicker learning these shortcuts. So what it says here, use the shortcut to determine order. So which one are you going to use, A or B? So we got to go back. Well, A is the one that says the numerator and denominator have the same degree. B is the one that says the denominator is bigger. We'll use A. Why? Because it's x to the first and x to the, again, those are the highest degrees, right? And what does the shortcut tell you to do? Basically, look at the fraction, right? So which fraction do you look at? Basically, get rid of everything that didn't have those highest powers on it. And look at the fraction it creates, the coefficients. What coefficient in front of this one is A? Coefficient in front of this one is A? So this is y equals, and y equals 1. Do you agree that is a horizontal line? Okay? And it should be just up 1, right? There it is. So we have found the asymptotes. Now we have to figure out where's this thing graph. So you remember when we did 1 over x, we learned that it did this, right? In general. How did we kind of learn that? I made you plot some points, right? And I'm going to tell you, this is about what they're going to do. Something like that. We just have to figure out, basically, is it above that asymptote or below? Okay? So we're going to do something. We're going to check a point. You can make a big XY table if you want, but I don't need you to do that. I just want you to figure it out, get a good sketch in there. So what I'm going to do you agree that there is a right side of that asymptote and a left side of that asymptote I just pointed to? So let's try something to the right of that. It's either going to be above the asymptote or below. Once you find out where it is, just graph it. I don't even care. So just pick something to the right of that asymptote. What is an x value that's to the right of that? Do you agree 2 is good? Is 5 okay? Is 10 okay? Are any of those fine? Yes, which one do you want to choose? I really don't care. 2 is probably the easiest, right? It's the smallest number. But if you want to choose 5, that's out a little further, or 10's out, it doesn't matter. So 2. Now how do I figure out what the y value is then? The actual y value. Plug it in where? In the function. So right here you're telling me for that x I should put a 2. Is that what you're saying? For that x, also put a 2. So what do I get if I put that in? I get 2 over 1. So it's 2 comma 2 is an actual point on that graph, right? So how many points on this graph have I actually found so far? 1. I found a lot of places where it can happen. All right, but really so far I've only found one that actually does, and that's 2 comma 2. Do you agree that point's right there? So where do you think that graph is going to be? The asymptotes basically pull the graph towards it. So it pulls it that way and it pulls it that way. That's where that graph has to be. The asymptotes don't give it a choice. So what do you suppose we're going to do to figure out where the other stuff is? So should I pick another one to the right of that asymptote? No, we already know where that is. Pick to the left. And what's by far the easiest one to choose there? 0, right? Is negative 10 okay? That's fine. But 0 I think is just way easier. And so what you got to do is you put a 0 in there over 0 minus 1, right? So it's 0 over negative 1. So it's 0 comma 0. Because 0 on the top is fine. 0 on the bottom, no good. So it's 0 comma 0, right? Right there. And what's it going to do? It's going to get pulled towards that asymptote and pulled towards that one. They will not connect. Okay? Now, for those of you that do have the graphing calculators, they basically get confused. The graphing calculators are told to connect things. So here's what your graphing calculator does. I think if you have the 84, it doesn't do this anymore. Here's what the 83 does. Oh, I got a point, I got a point, I got a point. Connect it. Keep connecting them, keep connecting them, keep connecting them. There's the next point. Connect them. So it just goes, flies right through your screen, and then it says connect them, connect them. That's all that knows how to do. Okay? And so that's why it's a little annoying. It just flies through your screen with a line and then does the rest of it. Okay? Now, what I want you to do is think why this shortcut works. Do you agree as x gets big out this way, like maybe 10 or even 100, or maybe way down in Mr. Brooks's room at 1,000,000? Imagine if you put 1,000,000 in here. 1,000,000 in for x. So we've got 1,000,000 in right there, and then 1,000,000 minus 1. Does that minus 1 have a whole lot of power at that point? What has the most power is that x value, right? And that's a big x value. Do you agree with that? So do you agree that's really close to 1 at that point? You agree with me? Now what if, so does everybody realize that we're done with this problem, right? Do you agree that the degrees are still the same, right? So this would be y equals 1/2 now, would be your asymptote, right? But you agree, do that million thing again. If I put 1,000,000 in there and I put 1,000,000 in there, do you agree the bottom's going to be about twice as big as the top? Because does that minus 1 again have a whole lot of power in that situation? Not really. It has no power. I'm subtracting 1 from 1,000,000. So do you agree that's going to get really close to 1/2? But no matter what x value I put in, is it ever actually going to be 1/2? No, it won't, will it? How about this one? Go back to that one. If I put 1,000,000,000 in both of them, is it actually going to say 1? Is it going to be extremely close to 1? But it's not actually going to be 1, is it? So do you see how close this gets to 1 as I go out? By the time I get to Brooks's room, do you think I'm even going to be able to see the difference between the asymptote and that graph? No, that's going to be so small, you're not going to be able to see it, but it's never going to get there. Okay? Same thing as that gets really negative. Same thing. That negative 1 right there, that has no power. Nothing. Okay? So that's why that shortcut works. Okay? So any questions on that? Do you see how that shortcut was a lot simpler than finding the inverse? Way easier, right? Okay, let's try another one. Do you agree it's rational? Yes. There is a variable in the denominator. In fact, that variable is squared. Does this one look more complicated or less complicated than the last one? Less? Okay. Look at the numbers that will make the denominator 0. Because remember, the denominator 0 is bad. So how are you going to solve this? Minus 2. So minus 2, minus 2. So x squared equals negative 2 square root. Housify. Plus or minus I squared 2? How do you graph that? Yeah, you can't. Not on an xy axis. On an imaginary axis, yes, you can, but we don't have one of those. So wait a minute. Does that mean, can anybody come up with a real number that'll make the denominator 0 then? Can you actually come up with a real number that'll make that happen? No, you can't. So this tells you vertical asymptotes, right? So does this graph have any vertical asymptotes? No. So just because it's rational, you're not guaranteed to have vertical. Can they happen? You bet. So there are no vertical. And this is the one where I'm setting myself up here a little bit. I hope it makes sense to you once I go through this one. This is an important one. What's the degree of your numerator? Degree of your denominator? Wait a minute, the bottom is bigger, right? Bottom's bigger. Garrett, you agreed? So this is that automatic answer. Y equals 0. Okay? Now this is the one that's going to trip you up a little bit. I'm not going to have you waste time finding these points. I'm just going to kind of show you what this does. This is an extreme special case, and I said, you know what? Let's just get it out of the way right away. Instead of me sneaking one up on you and you getting confused. It crosses at -1 is where it crosses. Like I said, I'm going to get this out of the way right now. Yeah, I'll just make like a snake-looking thing. Okay, here's the key. Vertical asymptotes cannot get touched. It is impossible. Horizontal asymptotes cannot get crossed as x gets way out. As x gets big, there are rules. You can't cross it. As x is small, you actually can. Well, let's see if we can figure out why. Let's do the same thing I did before. Let's make x huge. 10 million. Okay? 10 million plus 1 on top. So does the plus 1 really do much for us? Not really. 10 million squared on the bottom. Plus 2. So again, the plus 1, the plus 2, a lot of power here? Not really. So we've got 10 million over 10 million squared. What happens if you have a number over a much larger number? And then you make it worse. Big number over an even way bigger number. What is that actually getting closer and closer to? That number. 0. What if you do negative? Negative huge. Negative huge squared gives you that. -0, if you want to call it that. But what if it's small? What if x is small? What happens to what happens when you say you take a half and you square it? Does it get bigger or smaller? It gets smaller, doesn't it? Take 1/2 and square it, it becomes 1/4. So as x values are small, do you see how the bottom actually loses power for a while? The bottom loses power to the top for a very short period of time. Okay, and so that's when x is small, it can cross. Will it normally? No, I'm going to tell you right now, the ones you're going to see 99% of the time it won't. But I wanted you to see that it was a possibility so that you knew that. Most of the ones you're going to see are going to be these graphs, just like that. Do those. Don't worry about it. But you need to know that it can happen. But only when x is small. When x is big, you see how that asymptote pulls it right back to it. That asymptote takes control again. Okay? It got below, but yep, it pulled it right back. It got above, but yep, it pulled it right back down. It's somebody that was gaining confidence and then just got shattered. All right, says, I'm getting out of here. No, you're not. Okay, because x squared said, you're not going anywhere. You're coming right back on down. Okay? So questions on that little difference there? All right. Now that we got that out of the way, let's go do this one. What do you think about this one? Simple? Yeah. What? The exponents match. Wow, hey, we're starting to look for things already. Look out. You learned shortcuts, what, 15 minutes ago, and we're already starting to look for things. There we go. Powers are the same, right? You can probably, oh, let's face it, you can probably tell me horizontals in this one quicker than you can tell me verticals. You should almost be able to tell me the horizontal already just by looking at it. Okay, but let's do verticals first. Verticals. To find verticals, I want to find out what's going to cause a problem down there. What's going to make that 0? Is it possible something will make that 0? Well, I see one value right now that's going to make the bottom 0. And that's 0 itself, right? If I put 0 in there, that thing's doomed. All right? So what you have to do, though, is we have to set this equal to 0. That's how you figure out what will make that, right? Let's face it, in the first example, you knew what that was. It was what, 1? You got to look at it. No, it's 1. This one's a little harder. But this is why we worked on all that factoring before we started this chapter. Do you notice that all 3 of those terms have something in common? An x. Anything more than that, or is that it? Unfortunately, that's it, right? So you take it out. And then you have to figure out what remains if I take that out. Do you agree that's what remains? Now what? This is algebra 2 now. Basically, when you get factors like this, if it does equal 0, either this one has to equal 0 or that one has to equal 0, right? Because I'm multiplying them. So if either one of them 0, 0 times something is 0. So let's face it, you set x equal to 0 and solve. Okay, done. And you set x squared minus 2x minus 3 equal to 0 and solve. Not quite done. How do you go about that? Yes? Okay. I think she was going to do the plus multiply thing, is what I think she was trying to show me. Sometimes referred to as Pants method, technically known as key number. Yeah, for some of you, I know it's technically known as Pants. All right. So multiply to b, negative 3, add to b, negative 2. Is there a guarantee that those 2 numbers exist? Is there a guarantee that 2 numbers exist that'll make that happen? Well, there is, but they might not be nice. All right? So we only want the nice ones, really. How about multiply to be negative 3, add to be negative 2? Negative 3 and positive 1. Now, for the sake of what we're doing, I'm going to bring it up here just to review key number again, because I know some of you struggle. The technical long version of it is you bring this piece down, this gets split into the 2 you came up with. Because negative 3x plus 1x actually is negative 2x. Okay? And then bring this one down. Squiggle, you got to make sure you take the sign with the second half. And then all you do is take a look at what's in common on the left side. What is in common on the left side? X. What's left? X minus 3. So what has to be over here? For this to work, I have to have x minus 3. Can I actually get it? Yeah, by taking out exactly a positive 1 or a negative 1? Positive 1. So my factors are, and I can come back down here now if you don't mind, x minus 3 is one of the factors, and x plus 1 is the other factor, right? And I want to set those equal to 0. Once again, they're multiplied. So either one of them being 0 gets me to my goal. Okay, this only works for 0, by the way. So what's going to make this one actually say 0 if x is 3? What's going to make that one say 0? X is negative 1. Now, good thing that this question is only asking you to determine the asymptotes, because this thing has 3 vertical asymptotes. Lovely. I can bring that graph up on the graphing calculator in a bit if you want to see it. Now, the one I told you should have been able to tell me already is the horizontal, because that's where you have, imagine doing the inverse on that. Putting a y in all those x spots and solving for y, we'd still be here. Especially seeing one of you said, hey, they're the same, and knew the answer in what, a second? Why go through all that work if you can see it that fast? And what is the horizontal? Well, it's always got to be y equals. So it's y equals, right, it's the power here is 3, the power there is 3. You agree that the degrees are 3, that's the highest exponent. So then you just look at the fraction on there. It's 3 over 1 is, that's a lot quicker. So who can explain why that works again? Who was paying attention earlier and kind of explain why does it really boil down to just those coefficients? That just seems too easy. Why does it boil down to those two numbers? What did we do? Just put in some huge X and figured out what has the most power. You throw in a huge X, does that plus 7 have a whole lot of power in that numerator? If you're plugging in like 100 million. Does that have a lot of power, the 7? No. 100 million squared, does that have some power? It does, but compared to x to the third, not a whole lot. Negative 3x, does it have some? Yeah. Negative 2x squared, does that have some power when you plug in 100 million? Yeah, but nowhere near x to the third. So you'd agree that those two leading terms right there, the ones with the highest degrees, have the most power in this problem, unless x is small. But when x is big, they control things. So basically the rest of that doesn't have enough power to change anything. So it comes down to that fraction, 3. Okay? That's why. So any questions on that? Shortcuts are pretty nice, aren't they? Way better than finding that inverse. We'd still be working on it. We'd be here for a while on that one. Okay? Just to get y equals 3. Because we would get the same thing. And one last thing for today. Once again, we are to determine all asymptotes, but this is the one place where it's going to be a slight disadvantage that I did things out of order. So, well, we'll just make it happen. One thing that I said probably about a week ago when we did section 3-4 part 1 or day 1, I told you to always look for something first. And I emphasized always. I know it was a week ago at least. What are you always supposed to look for before you look for anything else? And you can take out 3-4 day 1 notes if you want. 3-4 day 1. Whoop. Yes, always look for. Whatever look for means. It's okay to be wrong. Just take a guess. Always look for. Nope, not constant. That's for odd and even. Good. Yes. Factors that cancel out, otherwise known as poles. Always. And how do you find them? Factors cancel off. Now wait a minute. Why didn't I say that on the last problem then? What am I doing here? Does that numerator factor? In the last example, does the numerator factor? No, so we didn't have to worry about it. Okay? This one does, so this one might have a problem. Well, let's factor them then. So always do that first. Always see if any factors will cross off. If your numerator doesn't factor, do you have to worry about it? No. How does something cross off if you can't even factor it? So go ahead and factor that numerator and denominator right now on your own. All right. Did the numerator factor? Yep. Has to multiply to b. -6 add to b. -1. And those numbers do exist, and they are nice numbers, and they are -3 and +2. Now, seeing there is a 2 out front, you cannot use that shortcut that I know some of you already know. So you have to actually go out the long method and finish this one up. So negative 3x plus 2x minus 3. Again, these do actually combine to be that, so it is the same problem, just looks considerably different. Take the sign with the second half. There, well, what's in common here is x, right, left with 2x minus 3, right? So I have to have a 2x minus 3 over here, which luckily I do, but I still have to put something out front, and it's a positive 1. So your factors are x plus 1 and 2x minus 3. Do you agree with that? And do you agree that's your numerator? Okay, so it's x plus 1 and 2x minus 3. That's our numerator. How about the denominator? Is there anything you can do there? Can you key number factor it? No, you need 3 terms to key number factor. You don't have 3. But they at least have a 3 in common, right? And do they have any more than that? Yeah, well, let's do, can I erase the key number or no? We're good? All right. So it's 3x to the third minus 3x. You told me a 3 in common. Anything else? X. So then what's left? X squared minus 1. Unfortunately, we're not done factoring. Yeah, because x squared minus 1 is difference of 2 squares. What do you have to square to get x squared? Well, x. What do you have to square to get 1? 1 plus minus. So is there any more factoring I can do to the denominator? Anything else factor? Nope. So it's 3x, x plus 1, x minus 1. So again, if you have not made a note that you should always look for holes first, you may want to do that. And as we were just told, to find holes, you have to look for factors that cross off. Do we have any? Well, if I'm going to emphasize looking for holes first, I'm guessing there probably is. X plus 1 does cross off. Now, technically, this is saying looking for asymptotes, so I really don't have to write down that there's a hole. But if you want to, you could go off to the side and say there's a hole at. Now, what do you do with what you cross off? Set it equal to 0. Okay? And if I set that equal to 0, x would equal negative 1. And now I don't have to worry about that anymore. It is gone. So what remains is 2x minus 3 over 3x and x minus 1. Do you agree that that is what remains? It's still there. Once you find holes, cross them off. Then you look at whatever's left over and you do step 1 and step 2. Find the asymptotes. Is it still rational? Still is. So what do you do? Step 1 says set the denominator equal to 0. But the nice thing is guess what? The bottom's already factored for you. So that's nice. So you set 3x and x minus 1. You have to set the denominator equal to 0. Well, set 3x equal to 0. And x minus 1 equal to 0. So from this one, what do we get? X equals 0. And from this one, we get x equals 1. What are these? Asymptotes. And are they vertical asymptotes or horizontal? How do you know they're vertical? Because it's x equals a number, right? Now what? Oh yeah, horizontal asymptote. I will be honest, I am trying to trick you. I want you to say 2/3. I want you to say 2/3. Because what's the degree of the numerator? It's 1. What's technically the degree of the denominator? If you multiply it out, it's squared, isn't it? So it's the automatic, bottom's bigger, automatic answer 0. I saw a lot of you saying that too. Very good.
Yes.
Now, what some of you said is look at the original. Is that okay? If you're going to cross off the same thing from top and bottom, aren't you taking 1 from both of them? So is it okay to look at the original? It is. It's fine. But I was trying to trick you to see if you'd tell me 2/3, and you didn't. Okay? Some of you asked, or one of you asked, well, what does it look like if it does have multiple? I'll just show you this graph quick. You will never really be responsible. If there's multiple vertical, I'm not going to ask you to do that. But I'll just show you what this one looks like. There's x equals 0, x equals 1, and basically here's what it does. Well, whole, right, at -1. And then there's a little really skinny parabola in here. Okay. Again, you're never going to have to do one of those by hand. That's about what it looks like. Okay? So if I give you a rational function, what should be the very first thing that pops into your head? Look for a hole. Then, bottom equals 0, and then little shortcuts. Who can tell me the 3 values that will make the bottom 0 in the original? There are actually 3 values. They're up there. 0, 1. How come -1? That's a hole. But wouldn't it, if I put -1 in here, doesn't it still make the bottom 0? It does. So was it there to begin with? Yeah. You put -1 in here, it's going to make the bottom 0. It's one of those that we took out, basically. We removed it.